Welcome everyone to the by now traditional Tech Leaders panel at OC3. I'm Felix Schuster, CEO and co-founder of Edgeless Systems. And it's fantastic to once again moderate this discussion with some of the key people shaping the future of confidential computing. This year's panel is titled Confidential Computing in 2026, a reality check on adoption, security, and sovereignty. And we have a lot to discuss. Where do we stand with bringing confidential AI to production? How do hardware vulnerabilities affect trust? And what does sovereignty actually mean in a world where workloads span silicon, firmware, operating systems, and whole cloud infrastructures? And how can confidential computing help? To explore these questions and more, we once again have an outstanding panel of industry leaders assembled here. Joining us today are Anand Pashupathy, VP and General Manager for Product Assurance and Security at Intel, Ravi Kuppuswamy, Senior VP of the Compute and Enterprise AI Solutions Group at AMD, Rohrer, VP Security at Nvidia, and this year, for the fourth time in a row already, our long-term guest and supporter, Mark Russinovich, CTO at Microsoft Azure. Together, the companies represented here shaped nearly the entire confidential computing stack, from CPUs and GPUs to platforms and AI infrastructure. Amazing. Gentlemen, thank you so much for joining us today. Well, we have a lot to cover. Let's dive right in and start with a reality check. Mark Russinovich, in the past years in this panel, we talked a lot about confidential AI as an emerging paradigm. What turned out to be harder than expected and what turned out to be easier than expected with regard to confidential AI and bringing it to production?
So I think what's been, I wouldn't say harder than anticipated. It's just been a challenge. And that is that we're right now have confidential AI acceleration that supports models that fit on a single server. We don't have the support for models that span servers. And so that limits a little bit the kinds of models that can be implemented with confidential computing, also the kind of training that you can do with confidential computing, with performance overheads that come with those limitations. We don't have the GPU to CPU hardware acceleration either in place yet with the current generation of hardware that's coming as well. So we're in an early phase of confidential AI, and already we're seeing adoption and tremendous interest in confidential AI. But I think that when it comes to scale adoption, the next generation of hardware that's coming out that addresses these limitations is really going to open the door to a lot of adoption and much more interest in using confidential AI.
Makes sense. And how do you see customers adopting this? Do they understand the property? Do they want it? Or does it require lots of explanation?
So when it comes to confidential computing in general, we see a spectrum of understanding of confidential computing and its the kinds of promises it can make. One of the things that I introduced at a conference, Confidential Computing Summit last year, is a terminology that I think can help people better understand how they're using confidential computing and what kind of protections they get as they use it. And that is a spectrum that starts with, of course, non-confidential computing, where you're performing all of the computation unencrypted and open with all the threat surface area that you've got today and traditionally have had. The next click stop would be on confidential computing, which simply means that you've taken a workload that was running previously and lifted and shifted it into confidential computing virtual machine or a container, that you haven't architected the application specifically to keep the data that is sensitive within what we're calling the confidential trust boundary. And you get some defense in depth properties out of that type of deployment. But you really start to get a lot of the promises of confidential computing when you go in confidential computing, which means that you've designed the application specifically to keep the data entirely within a confidential trust boundary, completely protected by software, by confidential computing hardware, or through encryption throughout its entire lifecycle. And that is actually somewhat difficult. You've got to manage keys, you've got to have mutual attestations and trust built along all the components that are communicating with each other. And so that is where you start to get into some complexity that comes with architecting the application well. And just for the record, the third click stop is transparency, where you're actually measuring all the code that goes into the confidential trust boundary and recording that in a ledger and can make a cryptographic connection between an attestation and the source code that went into that attestation. But so I think that's where the complexity shows up in any kind of confidential computing solution, including confidential AI solutions.
Maybe I'll just add a quick one, right? I think sometimes there is the harder than expected is the ability to understand the nuances of what is confidential AI. Okay, meaning sometimes people don't quite have the perspective of what it does and when it's supposed to do. But the easier than expected sometimes is once they understand the simplicity that it protects the models and allows for shared development, I think you get executive buy-in much faster than originally expected. Anyway, just wanted to add to what Mark was talking about.
What I've noticed is, it used to be much harder to convince somebody about confidential AI, but now with the advent of being able to show it, I think people get on confidential AI immediately and say, I want it. Then we go through some of the harder than expected ideas that Mark was talking about, the hardware not being there to the right level of performance, et cetera, which is coming. It just is not available right now.
Yeah, got it. Now, I also see the excitement around AI, especially here in Europe. But what we also saw, Anand, was that to some extent, customer trust has been impacted by suspected hardware vulnerabilities that were published over the last 12 months. From your perspective, how do these affect perception of confidential computing, and are these problematic practice?
Yeah. Felix, I think over the past 12 months or so, I think we have seen a lot of high visibility research papers, which have been looking at hardware attacks on trusted execution environments, including papers that have put a memory interposer to mount some of these attacks. And these studies are extremely valuable, but they often assume that an attacker can gain access to a physical system, that the hyperscalers and enterprises work very hard to prevent access to. And in practice, when you add physical security, you add platform attestation, you add lifecycle management, and fleet level monitoring, the threat picture looks very different than the studies that are done at an academic level. And the way this is, I believe, shaping the confidential computing conversation, it's actually very clarifying in a good way, because people shouldn't think of confidential computing as a magic force field. T's are hardware and firmware, and like every part of the platform, they get researched, they get CVEs, and they get patched and updated. And this shift is healthy, I believe, because customers are moving from broad market claims on confidential computing to focused conversations about threat models, evidence, operational maturity, et cetera. And they're asking the right questions. What exactly am I protected from? What is the residual risk in my environment? And how do you prove that the platform state is what it is? And these are all signs of a maturing ecosystem. Now, are these really problems for confidential computing? I still believe that the dominant threats that enterprises care about are really from privileged software attacks, hypervisors, operators, debugging interfaces, et cetera. And the TEs still deliver strong isolation, encryption, and attestation against those. And these vulnerabilities in firmware and implementation do matter, but we handle them the same way we handle other features, patching, measurement, validation, updating attestation policies, et cetera. And while confidential computing is powerful, and this is key, it is not a turn on and forget about it technology. It's on the customer side, the real deployment needs lifecycle management, including update cadence and clear processes, so updates don't break broad-based verification. And when both these sides, both the customer side and the organizational side, execute effectively, the residual risk becomes manageable, and CC remains the most scalable way to protect data in use across cloud, enterprise, and sovereign environments. And I think the conversation should really move to total cost of ownership trade-offs. As Simon Johnson said in an earlier keynote session, at the end of the day, the acceptable security envelope is going to be defined by balancing security assurance, performance, and cost. And every innovation must fit within that TCO boundary to be widely adopted. And that's why the industry path forward is so encouraging. And I'm not going to disclose that innovation agenda. You'll have to listen to Simon's talk to understand that more. To me, the bottom line is that the last 12 months haven't weakened the case for confidential computing. They've actually strengthened it. We now have better threat models, better conversations with customers, and a clearer roadmap of how to continue boosting protections while staying inside these real-world TCO boundaries. That's exactly how a mature security technology should evolve, and that's the evolution we're seeing right now.
I couldn't agree more, and I especially like the notion about the magic box. Thank you, Anand.
I think the magic box holds a very complicated virtual machine, which a lot of problems can arise from in that deployment. So the total risk view, I think, resonates very strongly. I think one of the areas, and you highlighted just the affirmative recovery of the confidential compute TCB, which I think is notable, but backed by attestations, so you can actually, as a workload owner, tell that it in fact has been resolved to your satisfaction at a very explicit way. And maybe echoing a little of Mark's observation before, a lot, I think, of what's happening in confidential computing and the computing ecosystem is converting what used to be sort of implicit trust models to much more explicit transactions in trust, starting from attestations, but chain trust through, signed containers and signed models and a lot of other elements that are being chained together to allow much more dynamic understanding of the integrity of the systems that we're deploying, again, on-prem, in the cloud, what have you, to base our decisions on. And I think that's going to be incredibly powerful in 2026, especially as we get to dynamic, sort of highly autonomous agentic workflows where that sort of real-time negotiation of trust is going to be endemic in pretty much every important enterprise workload we see.
So another hot topic is, at least here in Europe, recently has been sovereignty. Not so much sure about the US, but I hear it's also a thing over there. So Daniel, what do you think is the role that confidential computing can play in the broader context of sovereignty, data sovereignty, sovereign AI, all these buzzwords?
I mean, in principle, for me, sovereignty is really about giving agency and control for data owners and workload owners in terms of how their workloads operate. And to the extent that confidential computing builds out primitives, certainly for confidentiality, sort of the principle in the name in terms of encryption and in use, but also through attestations and being able to bind active policy decisions, that sort of implicit, explicit discussion we're having, I think that becomes really important. Vibrant, AI is energizing a lot of economic growth at every point in the globe. Not every point in the globe has the same set of concerns, right? And, you can imagine local models with very specific tuned behaviors, linguistic, if nothing else, to serve those local needs, and allowing sovereign control and sovereign purpose to it is really important. And being able to verify that is in fact the thing that I'm interacting with is equally important. And stitching all that together is really, I think, the promise of a lot of CC. We see areas like verifiable software. Hey, I can prove the software that was run, which allows operators to choose where they place their trust. And I don't really want to negotiate for, decide for others where they want to place their trust, but having explicit ways for them to choose where they place trust and where they don't place trust, I think is really important to realizing that sort of sovereign control that we hear about so often. Sometimes that's expressed as, hey, I want a local data center. I'm not sort of stuck on that square. That's certainly an easy way to assert that trust choice as just sort of a package answer. As long as we have the tools to allow to transact in trust and allow those explicit decisions to the workload owners, I think we've met the need for what sovereign control really means.
I just want to add something to what Daniel just said, and the last part particularly where he talked about location and locality versus, the key point there is it's not just where it's located, it's actually who controls the data, who actually goes ahead and has access to it, and can you really verify it. And confidential compute essentially provides all of those tools essentially to go ahead and say, hey, I'm able to audit, I'm able to verify, data security and handling, and hence, that defines sovereignty in some sense, because otherwise it just becomes contractual. It's not verifiable. So that last part that Daniel made is very, very important.
So if I can also add on to this, confidential computing and sovereignty, I'm seeing, as Microsoft is seeing, as being synonymous. In fact, every one of the major sovereign deals that we've done, most of them in the EU, have been built on top of a foundation of confidential computing. One of the great examples of confidential computing being a cornerstone of sovereignty is our partnership with G42, who offers a service called Digital Embassy. The idea there is to give governments that don't have access to hyperscale clouds within their country borders the ability to stand up government workloads outside, but yet have assurances that they're just as protected and secure and compliant as if they were within their own borders. And that's provided by G42 on top of confidential computing, which gives the customers the assurance that their data is going to be protected and, again, auditable throughout its life cycle, as we've been discussing.
To me, sovereignty is about providing that cryptographic trust at the end of the day. And it's not about physical location. Even, sovereign or countries who have always looked for a physical location as a way to solve a sovereign problem are moving to confidential computing and using that as a way for providing that sovereignty and that cryptographic trust, which is very synonymous with what Daniel said and what Mark just said. And I think that's what Ravi was agreeing to as well.
Well, I think one of the things that surprised me a little bit, and where my head started when we went down the initial, confidential computing with Hopper, we're now on sort of the third generation for GPUs, but we were really trying to problem solve of how to get really sensitive data into the cloud. And while Sovereign and CC enable all of that, we're also seeing sort of the reverse direction. How do I get my model out of the cloud into an on-prem or a localized data center in the reverse direction? And it turns out CC works just as well in the opposite direction. So that very explicit trust is really enabling, I think, a lot of different models. And it may be why I'm not sort of stuck on the location square, because it turns out location is relative to what you're providing into the ecosystem. And really, we're just trying to enable a vibrant ecosystem of interactions between, model owners, workload owners, data owners, and enabling it under whatever trust model they need to service their, regulatory or business needs. And I think we've seen pretty much all of the patterns that you can imagine emerge somewhere in the ecosystem, EU and US.
That was a thorough discussion. Thank you for that. Maybe in connection with that, is confidential computing primarily a cloud-based technology, or are we also seeing on-prem and edge use cases these days? Ravi, what's your perspective on that?
No, thank you, Felix. Let me just say that it is primarily cloud-driven in the beginning, but on-prem is coming up sharp behind it. And the way to think about it is confidential compute is well established in the cloud. Okay, given the use cases of multi-tenancy and the fact that there is an environment in which you need to be protected using technical controls against other people housed in the same system, it is well formed in that space. Okay, also because of the fact that most enterprises or customers start their thing cloud first. They try out their stuff, they validate their models, they look at the operational work, and then move it to on-prem. Okay, so and then the third aspect of it is it's widely available. Okay, multiple cloud providers all provide this capability, and hence one can compare and contrast multiple models, pick the right one, and then get it to on-prem. So clearly, it leads in the cloud. Now, on-prem requirements is not just a copy of the cloud model. Okay, its needs are different. For example, data sovereignty and regulations are a big part of it. Industries and countries who while want confidential compute for both the capabilities that it provided and to the earlier point that Mark was making, attach confidential compute directly to sovereignty. Okay. And then there are places where there is a large data footprint, where data is not easy to move, back and forth, or there are enough performance and latency concerns when it comes to moving it. In those cases, you find on-prem to be more preferred, and hence it's coming on the heels of cloud. And then if you had to really look at it from a summary standpoint, you can think of it as cloud is the adoption engine. On-prem is where it's going to scale. And truly, if you look at it, the new frontier is in the edge. And it is people like all of us and the broader ecosystem to go make sure that we are able to enable all the facets of confidential compute to seamlessly operate between all of these three frontiers.
And is the motivation to use confidential computing on-prem and on the edge the same as using it in the cloud, or is it different?
So in my mind, like I said, it's different from the standpoint of the fact that your needs in on-prem is different than from the cloud. Like I said, the regulation and sovereignty requirements, the ability to audit. Even within on-prem, you want the ability to go ahead and maybe separate out functions. For example, in a company, the HR function is operating in one portion of the system, and then you have other functions, and you don't want them to be encroaching upon one another. And you have these needs and methods that are somewhat more attuned to on-prem versus what it is that you may be needing in the cloud.
Can I let me add something, Felix? Because I think if you take a look at the journey of enterprise to the cloud, it hasn't finished. But clearly, that's where the center of gravity is now, is cloud, and there's a lot of incentives to go to cloud hyperscale computing, the efficiencies and the agility that you get, the expansion that you get, the kind of scale that you get there that's hard to replicate on-prem, where you're managing your own data centers and infrastructure. That said, this transition is not complete. It's not like 100% of everything is in the cloud. And there are many cases where customers have workloads that are on-prem for one reason or another. The typical reason we see that things haven't moved, or maybe there's no plan to move them, are regulatory in nature, or because of there's a center of gravity latency concerns for keeping something outside of the public cloud. And then of course there's the whole edge, the whole IoT and edge scenarios. And I think when you talk about confidential computing, it provides you an extra level of security for all of those environments that it provides huge value, especially if you consider cases like I don't have necessarily the strongest physical security, or I don't fully trust the physical security around this. And confidential computing provides this very strong physical security defense layer around the computation. If you don't control the whole logical environment, and you're concerned about unauthorized code getting access to data that's being processed for some particular use case within that environment, confidential computing allows you to create this very strong container around or shield around that computation and keep the unauthorized code out of it. So it's got a lot of advantages, and I don't think on-prem or edge computing obviously is ever going to go away.
In my opinion, it's not a question of if, it's a question of when confidential computing is available ubiquitously across all the environments we're talking about.
Yes. Yeah.
We have to do it, though, meaning I truly believe the ecosystem has a responsibility in making sure that we are able to streamline, standardize, have the same, otherwise it'll get adopted. Like you said, it'll be a little later. Our ability to go ahead and streamline it with the same kind of rules and facets will be very important.
Well, if the people on this call can't do it, I don't know how else it's going to happen.
That's right.
Who else is going to? Exactly.
I mean, for confidential computing becoming ubiquitous, is getting remote attestation right the biggest challenge?
It's probably the most fiddly. As a technical matter, I don't know this is the most challenging, but it is definitely the one that I don't want to expose the user to any more than I absolutely have to. No one likes being asked to learn fiddly crypto to get their real job done, right? And I think that's where intermediaries and ISV integrators and a lot of the great work from Azure and others to make workload deployments easy and straightforward. You sort of click once, my container's launched, everything just works. I think is really important to just lower the threshold of activation, because it's not about the crypto, it's about the workload.
So we're almost at the end of our time. So I'd like to close this, or I could do this forever, but I have to close this, and I'd like to close this with a round robin question. So if we are sitting here again next year and are looking back, what progress would make you say confidential computing clearly crossed the tipping point?
To me, the tipping point would be when people don't look at confidential computing as a risk reduction technology, but an AI enabling technology. And people don't have to think about, do I want confidential computing or do I not confidential computing? It is just available to you for use. And, unlocking unregulated AI deployments, cross-organizational data collaboration, all of this will not proceed without a confidential computing environment being available. If I was sitting on Santa's lap, that's what I would ask for the end of 2026, 2027.
I just think that the tipping point would be if there was no nomenclature to say there is computing and confidential computing. It's just confidential everywhere. Okay, because it is no longer a nice to have feature, or it is a feature. It is in the bedrock of everything, like power and performance. It is the way of life. It is what everybody will trust and everybody will run with, and hence there isn't anything that is different. And it is table stakes. That would be the tipping point.
Agreed. Mark, what do you think?
I feel like Mark's got to have a view here, but I'll jump in front. I think the accessibility and ubiquity of CC-enabled compute capacity has certainly been a watershed moment. I mean, we saw the beginning of it several generations ago, but it's hard to find a major CSP or data center that doesn't have some amount of capacity to just run a CC workload, which is a huge change, because before there was always sort of should I bother investing down this path if I can't access the capacity to use it, right? So that's been huge. But I think interestingly enough, and maybe WhatsApp was an interesting example of taking CC and making it a value add for privacy, like a table, top known name of an app that everyone uses, using CC to improve the product and how it performed and how it delivered and serviced the market, I think was a really interesting moment. because a lot of times security is sort of in the background. It's not really talked about. It's not a feature forward thing. And I feel like CC has become much more feature forward as a value add into the discussion, as an enablement of the discussion, which a year ago we didn't really see nearly as often.
Yeah, and Daniel, that's a great example. I was actually going to mention that one, but I think there's a few ways to define tipping point. And I think one way to define it is just that everybody's talking about, there's high awareness of confidential computing, and we're seeing confidential computing being discussed across all enterprises. I think we're just about there when it comes to that. And we've talked about, for example, sovereignty and confidential computing being synonymous. That's a tipping point we hit in the last 12 months or so. I think another way to look at the tipping point is all of the reasons why you might be reluctant to put a workload into confidential computing just to get the value out of it, or going into that TCO boundary that Ravi was talking about earlier, or I think Anand was talking about earlier, is that all of that we've got no performance overheads or very little performance overheads for confidential computing. And no scale limitations with confidential computing. And we talked about earlier that I think that tipping point we're hitting in the next 12 months for sure across the hardware that's coming to market, that we'll be able to do large scale training, inference for models that span multiple servers, and have no performance regression as compute is talking to the GPUs. And we've got live migration support for confidential virtual machines and containers. We have all of those kinds of problems that are currently friction points with confidential computing will be gone. And that really is going to just unlock the doors for this to really go broad and make it so that the default can be confidential computing instead of having to worry, what's the performance overhead, or I'm going to have to deal with some working around some limitation here.
Thank you, Mark. Thank you, everyone. Thank you for sharing your thoughts with us. Great discussion. And I hope we can continue the discussion at the conference and also next year, maybe at a similar panel. Thank you very much and speak soon.
Thank you.
Thank you all.
Thank you. Thank you.